Assalamualaikum and good morning to our lecturer, Puan Hamimah. So today we would like to talk about matrices. First of all, what is matrices? A matrix is a rectangular array of numbers arranged in rows and columns. So in matrices, we have 8 types of matrices, which is the first one, row matrix. Second one, column matrix, square matrix, zero matrix, identity matrix, diagonal matrix, lower triangular matrix, and upper triangular matrix. Now, we are going to talk about the properties in matrix. So, basically, we have a total number of 6 properties. The first one is A plus B is equals to B plus A, which means A plus B is the same as B plus A. The next one is A plus B in the bracket plus C equals to A plus in the bracket B plus C. That shows that both of these are just the same. The next one is A plus in the bracket negative A equals to bracket negative A plus A equals to 0. The next one, alpha plus beta in the bracket multiplies with the A is same with the alpha A plus beta A. The next one is alpha in the bracket A plus B is same as alpha A plus alpha B. The next one, the last, alpha in the bracket beta A equals to alpha beta A. We'll go to the first one, row matrix. This is how row matrix looks like. Row means the row of the matrix. The next one, column matrix. This is the column of the matrix. Square matrix. Square matrix looks like this. Zero matrix means that all the numbers in the matrix is 0. Identity matrix. This is how the identity matrix looks like. Diagonal matrix consists of 0 up here and 0 down here. So this is the diagonal matrix. 1, 2, and 3. The next one is lower triangular matrix. Lower triangular matrix means that only the lower triangular of the matrix consists a number and the upper one is 0. The next one is the upper triangular matrix. Upper triangular matrix is opposite with the lower triangular matrix. As we can see, upper triangular matrix consists of the number only at the upper one of the matrices. Okay, now we are going to talk about the subtraction in matrices. As we can see, we have matrix A here and matrix B here. In subtraction, we just need to subtract the first row, first column with the first row and first column. So we have A11 here as 8 and B11 here as 4. So we just put 8 minus 4 here. That same goes to the other matrices also. So the answer is 4, 7, 1, negative 3, negative 3, 3, 3, 2, and 8. That's all for subtraction. Next, we have multiplication in matrices. For multiplication, it's not the same as subtraction. In multiplication, we need to multiply the first row with the first column, the first row with the second column to get each of the answer here. So here you can see that 8 multiplies by 1 plus 2, 3 plus 0, 4. So we'll get here 14. The next one, 8 multiplies by 2 plus 2 times 2 plus 0 times 5. We'll get here 20. The next one, we'll get 22. And the last one, we'll get 21. So this is the answer for the multiplication of matrix A and matrix B here.
Hello, I'm Hafiz. Today I'm going to tell you about transpose matrix. Transpose matrix, written as A transpose, is the matrix obtained by interchanging the rows and columns of A. Here is A. A11 equals to first row and first column. A12 first row, second column, and so on. If the A transpose become A first row and first column, we interchange the row and column. So become this one A first row, second column, and this one A first row and third column. There are 4 properties of transpose matrix. First, A plus minus B transpose equals to A transpose plus minus B transpose. Second, A transpose equals to A. Third, AB transpose equals to B transpose A transpose. And the fourth one, KA transpose equals to KA transpose where K is a constant. Let's move to the exercise. Let A equals to 1, 3, 2, 4 and B 3, 2, 4, 1 and C 1, 3, 4, 2. The question asks A plus B transpose. So let's do it. A plus B transpose equals to A transpose plus B transpose. A transpose is 1, 3, 2, 4 plus B transpose equals to 3, 2, 4, 1 equals to 4, 5, 6, 5. This is answer for A. Let's move to the next question, B. A transpose transpose. A transpose transpose. Let's see the properties of determinant. A transpose transpose equals to A. So A transpose is 1, 3, 2, 4. We transpose it, become A. So become 1, 3, 2, 4. Let's move to the next question, C. BC transpose. BC transpose equals to C transpose and B transpose equals to 1, 3, 4, 2, 3, 4, 2, 1. We will get 15, 20, 5, 10. This is the answer. Let's move to the next subtopic, which is determinant of matrix. The minor is the determinant of m-1 times m-1 matrix obtained by deleting the I row and j column of A. The cofactor of the element is this one, Cij equals to -1 I plus j mij. I is referred to the row and j is refers to the column. There are 4 properties of determinant. The first one, Ka equals to Kn determinant A, where K is scalar and N is an order of matrix. Second one, determinant of AB equals to determinant of A times determinant of B. And the third one, determinant of A transpose equals to determinant of A. And the fourth one, the value of determinant changes sign when 2 rows or columns are interchanged. Let's see the exercise. Given A, matrix A, 1, 3, 1, 2, 2, 1, 3, 4, 3. The question asks, find the adjoint A. First, we need to know the minor and cofactor first. The cofactor is, inside is minor. Minor first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column, third row, first column, third row, second column, and third row and third column. So, let's do it. Cofactor. Like cofactor, the sign inside is plus minus plus, minus plus minus plus minus plus. So cofactor of first row first column, minor. This one is the minor. This one is all the minor. So cofactor for it, the formula for minor is AD minus BC. So the cofactor is 2 times 3 minus 1 times 4. So 6 minus 4 equals to 2 and so on. So adjoint A, is equal to transpose of cofactor matrix. Cofactor matrix for this one, we interchange the row and column, become like this. And adjoint A is 2, -5, 1, -3, 0, 1, 2, 5, -4. So adjoint A is basically transpose of cofactor. Thank you.
So this is inverse. So to find inverse, we have two methods. One of them is adjoint method. Second one is ERO, elementary row operation. So the first one is adjoint method. To get adjoint, we have the formula adjoint A equals to cofactor transpose. So let's do this question. Given the matrices 2, -1, 1, 0, 1, 0, 1, 3, -1, and 4. If determinant A equal to 2, find the inverse matrix of A using the adjoint method. Alright. So we need to find the cofactor first. You know the AD minus B, AC minus BD, and then the diamond, we will get the cofactor, and then we just transpose it. Transpose is you change the position between the column and the row. We will get the CT. You get the cofactor T transpose. You just get in the formula. This is the formula to get the inverse for in adjoint method. Alright, 1 over determinant multiplied by adjoint A. So you just put in the information in the data. A inverse equals to 1 over 2, and adjoint A just multiply inside and we will get the answer. So this is the second method, ERO. The question is, find the number of matrices by using the elementary row operation method. So we need to find the inverse using ERO method. Alright. So we let A first, and then first we need to circle this both two, and the second row and the first row on the first column, 1 and 2. And then we make a cross multiplication. R2 is 1, the data is 1, R1 is 2, and then we will get an equation. Keep in mind that we don't take the sign, negative and positive, we doesn't take it. And if the sign is different, it will become plus, and if it is the same, it will become minus, like this. Positive and positive, we will get negative. Okay, we just do the same as there are for the third row also. We have the row 1, and then second row, and then after that the first row keep remain the same. It doesn't change. 2, 1, 1 and 1, 0, 0, 2, 1, 1, 2, 1, 1, 0. And then the second row is unchanged. The second row is unchanged letter, and we just do the same, make a cross multiplication, and we'll get the equation to change the first row and the third row. As usual, the second row is unchanged. After that, we will get all 0, unless it is the identity position, like in this 2 to -2. So this is the identity position. So we need to make to change it back to 1. Then we make a equation to change it back to 1. And we will get this. We get an identity over here, and then this is the inverse for it. So we get the answer. So for elimination, one of the method is the Gauss-Jordan method. The question is, solve the following system of equation system using the Gauss-Jordan elimination method. So we use this method because we have too many unknowns, like 3 unknowns at the same time. So we put the variable weight, and we take the constant value only, and put it in a matrices form like this. We take the equals to, put it beside it. So it's similar to the ERO method. We need to find we need to make the left side is identity. So we make cross multiplication as usual. We will get this the equation. We will get the answer. This will be the same, and then we will get the identity, and this is the value for the unknown unknown variables just now. X is equal to 3, y is equal to -5, and z equal to -2.